Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at National College of Ireland, and in this short video, another video in our series of videos dealing with linear programming, we're going to look at a particular example, okay, an optimization example. The previous video to this, we looked at the concept of equations of lines and inequalities, just so that we could understand, I suppose, how particular lines and inequalities split the xy plane up into two regions, and that these were important constructs for us, and that these constructs were going to help us with solving these linear programming problems. Okay, in this particular example, we have an investor, and the investor has €12,000 to invest, and they've been given two particular options, either bond A or bond B. Okay, and both options have a particular return expected with them. Bond A has a return of 12%, and if she invests or he invests, or if the investor invests in bond B, they could expect a return of 7.5%. Although bond A has a higher risk in comparison to bond B. Okay, and the job here for the investor is to maximize the return, but also in mind is to try to minimize our risk. Albeit this particular example doesn't give us any objective function with respect to risk. There's no specification on the actual risk associated with the both bonds, so really all we're going to try to do is to maximize the return in this particular example. Okay, now there is a set of constraints. Okay, there are constraints. Actually, in the first paragraph there is actually an implicit constraint in relation to this particular problem, and it's that the investor has €12,000. So irrespective of what they invest in bond A and bond B, the total amount that they invest in bond A and bond B can't be any more than €12,000. Okay, so that's actually a constraint that we have. Yeah. So maybe what we'll do is we'll list down all the constraints, or maybe we'll list down the objective function first of all. So the objective, okay, function in this particular instance, okay, is, well, it's what they expect to get in return, yeah, for their investment. They're going to get 12% of whatever they invest in bond A. So let's say A represents the number of bonds A that they've bought. Okay, so they could expect back 0.12% of A. And what they can also expect as a return is 7.5%, 0.075 return on whatever they invest in B. So in this case here, A represents how many of stock A we've bought, and B represents how many of stock B, or how many bond A types we've bought and how many bond B types we've bought. And this particular function here, okay, let's say that the output of this is Z, so let's say that this is Z is equal to this. This is what we call our objective function, and depending on how many of A and B that we buy, depending on how much we invest in A and how much we invest in B, we get an output. And the job of this linear programming task is to make sure that we choose the right values for A and B so that we maximize our output. But we maximize our output relative to all the constraints associated with the particular question at hand. And as I said, the first constraint, which it doesn't really list that as a constraint, it's sort of implicit, is that the investor only has €12,000. Okay, so irrespective of what they invest in A and B, the totality of them two investments, the totality of those two investments can't be any more than 12,000. So our constraints, with respect to this particular problem, the constraints are, the first constraint is that A plus B can't be any more, so it must be less than or equal to €12,000. Okay. The investor also has decided to invest at most €7,500 in bond A. So what we now know is this, is that the amount that we invest in bond A can't be any more. It's at most 7,500, so it must be less than or equal to 7,500. Okay? And also they expect to invest at least 1,700 in bond B. So they're going to put at least 1,700 into bond B, which means that the amount that they invest in bond B is going to be greater than or possibly equal to €1,700. Okay? And then the final constraint that we have here is the investor also wants to ensure that they invest at least twice as much in bond A as they do in bond B. Okay? What does that mean? Well, that means if you tell me how many bond Bs you've bought, okay, if I multiply it by 2, well then A must be at least that value. So then we have that A must be greater than or equal to 2 times how many we've invested in B. So we have now 1, 2, 3, we have 4 constraints, and based off these constraints we'd like to find the appropriate A's and B's that maximizes this particular objective function. Now what we're going to do is we're going to create an axis system here, an X and a Y axis, but the X axis is going to represent, the X axis is going to represent how much we invest in bond A, and the Y axis is going to be how much we invest in bond B. So I'm just going to set these axes down here. There's sort of an implicit